All right, let's dive in. We're talking about one of the biggest, baddest mysteries in the whole universe, black holes. You know, these invisible giants that literally bend space and time? Yeah, those. We're going to get to the bottom of what they really are, right to the very edge of what we know about physics.
Okay, so let's start with a really simple but huge question. We all know what gravity feels like, right? It keeps us on the ground. But what if you could crank that force up way, way up? Like what happens when gravity gets so ridiculously strong that nothing, and I mean nothing, can fight?
Well, what you get is a black hole. It's just an object that's so unbelievably dense, with so much stuff crammed into a tiny, tiny point, that its gravity just creates this bottomless pit in space. It's a literal point of no return. So let's really break that down. What actually is a black hole? Okay, here's the simplest way to think about it. It really just comes down to two things. First, you need a crazy amount of gravity. And second, that gravity is created because you've squeezed a whole bunch of matter into a space that's almost impossibly small. This is a great way to picture it. Think about escape velocity. Here on Earth, if you could throw a rock at about 11 kilometers per second, which you can't, but if you could, it would fly off into space and never come back. It's escaped Earth's gravity. Now, with a black hole, the gravity is so intense that the escape velocity is faster than the speed of light itself. And since we know nothing can go faster than light, well, that's it. You're not getting out. That's the point of no return we keep talking about. So that makes you wonder, right? Where do these things even come from? And are they all the same size? Turns out, nope. They come in different flavors. Yeah, check this out. You've got these tiny ones that are still just a theory. Think about the mass of a whole mountain squeezed into something the size of an atom. Crazy. Then you have what are called stellar black holes. These are the ones formed when a massive star dies and collapses in on itself. And then you have the big ones, the supermassive black holes. We're talking millions or even billions of times the mass of our sun. These guys are the anchors of entire galaxies. Okay, look at this number, 4 million. What in the world could that be related to? That is the mass of the supermassive black hole right in the middle of our own galaxy, the Milky Way. Its name is Sagittarius A star. It's got the same mass as 4 million suns. Just try to wrap your head around that scale. It's almost impossible.
Okay, so this creates a pretty big problem, doesn't it? If they're black, meaning no light can escape, then how do we see them? How do we know they even exist?
Exactly, we can't. You can't just point a telescope and snap a photo. So scientists have to become cosmic detectives. They have to look for the evidence, the fingerprints that a black hole leaves on the universe around it. And this is basically how they do it. First, they see a star that's, well, it's dancing with an invisible partner. It's orbiting something we can't see. Then, they do the math on that star's orbit to figure out how heavy its invisible partner is. If it's super, super heavy, that's a big clue. And the final piece of the puzzle is looking for this super hot, high-energy glow, like X-rays, which happens when the black hole is pulling in matter from that star. So, the key thing to remember is this. We're never actually seeing the black hole. We're seeing its effects. We see the way its immense gravity messes with the stars and gas clouds around it. That's how these invisible giants end up telling on themselves. All right, let's get to the question that's probably been nagging at you this whole time. Are we, going to get eaten by one of these things? It's time to separate the movie plots from the real science. So let's just put it out there. Is Earth in danger? And the answer, you'll be happy to hear, is a big, fat no. I love this quote because it makes it so clear. A black hole is not a cosmic vacuum cleaner. It doesn't just roam around the universe sucking things up. And here's why. Gravity just cares about two things: how much mass something has and how far away it is. So let's say you could magically snap your fingers and replace our sun with a black hole that had the exact same mass. You know what would happen to Earth? Nothing. We'd just keep orbiting it like we do now. It would just get very, very cold and dark. The pole would feel exactly the same.
And just to really put your mind at ease, the closest black hole we know of is 1,600 light years away. I mean, that is just a ridiculously, mind-bogglingly huge distance. We are absolutely 100% safe.
Okay, so if they're not going to eat us, why do we even care? Why spend all this time and money studying them? Well, it's because black holes are basically the universe's most extreme science labs. I mean, think about it. By looking at them, we can actually test Einstein's wildest theories about gravity and space-time. We get to see what happens to matter when it's put under pressure we could never, ever create on Earth. We can even detect these things called gravitational waves, literal ripples in space and time, which can tell us about how the universe itself began and how galaxies like ours came to be.
At the end of the day, black holes are where matter goes to die. They are the ultimate endpoint. They're these places where our understanding of physics gets pushed to the absolute limit, and maybe even breaks. They force us to accept that the universe is so much weirder and way more incredible than we could ever imagine on our own.
So yeah, they're the ultimate cosmic puzzle. And when we study them, we're not just looking at some weird, dead stars. We're actually asking questions about the nature of reality, space, and time itself. It really just leaves you wondering, what other massive secrets about our universe are they just waiting to tell us?